is surface-based, and more or less by definition, pipe data is acquired using subsurface means, RV, AUV, or whatever. So a little bit of post-processing related to subsurface scenarios. Let's have a look and see the or finalize the exercise from yesterday. A little bit disappointing. I've only received exercise from 3 of you. That's yeah. Okay, I'm just writing down or reading Duong's comment. Yeah, I can understand your confusion. The only thing I can say about that is that you shouldn't be confused after a training course like this. But I would say this online-offline training course, I mean, a normal online training course is 5 days, a normal offline training course is also 5 days. So it's really squeezed down into 5 days. So what I would recommend, because if you're really in doubt, Duong, I would go and have a look, because it's described in the e-learning. I know, because I wrote some of it myself. I'll see if I can find time to talk about this, of course. But I mean, this is really a condensed training course. But I'll do my best. Anyway, what you can see here is my terrain model after it has been cleaned. I took an area over here that hasn't been cleaned so that we can just have a look at it in the one editor cleaning or manual cleaning tool. So one of the things I didn't tell you yesterday is the possibility of, well, the default is reject mode. As you can see here, the alternative is accept mode. So if I go into reject mode and reject an area here, then the accept mode will, of course, do the opposite, as you can see. There's another thing that I can show you. Now I'm in reject mode again, and that is this icon here, where I am also showing deleted points. As you see here, the grayed out points are points that have been deleted. Can sometimes be beneficial to have a look at the data like this, so you can see what it is that you are missing. I'll just accept these points now. Now they're back, and of course, could also be something underneath here that is then being removed. But let me just get rid of the noise. I hope that you got the message yesterday. I was trying to tell you a few times, actually, that it's not so important that you go, in this particular case with the training, that you go into the details, smallest of details. What was important was that you would try all the methods. That's also why I told you to just give me a couple of screenshots or something like that, because it's also very difficult to get for you to document what you have done. So now I'm of course doing what I tell you not to do, but not so important. Rejecting these points here, but of course I'm the teacher, so it should be fine what I'm doing. Yeah, I've gone into the so-called cleaned regions modes again, cleaning and the column mode cleaned regions. Of course, I can go back to depth, which is default. And if we try to compare this to yesterday, you can of course see, I hope you can see that it is looking substantially better than it did yesterday. That, of course, was the purpose of all of this. So once I have done this, I will press the Save to External here. I haven't done that before, which you can see here. Navi model knows exactly what blocks have been modified and have not been written back to the NaviEdit database. External in this context is the NaviEdit database. So I will say OK to that. OK. And now it's writing back. I can, of course, open the job list, and then we can see that it's writing back and progressing. Yeah, good morning, Raymond. I'm right now I'm looking at the exercise from yesterday. I've got my terrain model that is cleaned. It's now in column mode depth. Doesn't have to be in column mode depth in order to be able to do that, but I'm saving to external. What is important to understand is that the only thing I'm doing is I'm writing back the cleaning status for all points to the NaviEdit database. I cannot move data or well, I can do that in NaviModel if I want to do that. But if in case I do that, then I should not write back to the database. Data flow. If we look at it, see, I am this connection to the SQL database from NaviModel is really a two-way street. I can load the data. This is what we did yesterday to create the terrain model, and I can then write back to the SQL database. And that's what I'm doing right now. And it says now been completed. If I look at my project, again, right-click on the project here at the top of the project tree and open the toppings folder. And then you have the terrain model itself here, which is living on a hard drive. And then I have two score patches that are related to the score scan method. This is basically giving us the first step of score. If they are here, then the score is available here on the regions scan. That's these two here, this area and that area, basically. But as I said, this project is only created so that we can clean the data. Once we're creating a real project, we will actually, or a real terrain model, will actually, the terrain model that we'll be working with, we'll do that on another project. It's not necessary, but I think that is the better way of doing it. I'll close NaviModel and then go back to NaviEdit. And again, I don't have to close NaviModel, but I do that to avoid any confusion with what we have here. You may remember from yesterday that we had some sound velocity profiles. We're going to apply the sound velocity profile to the multibeam data. But in order to be able to do that, we need to load the different sound velocity profiles into the NaviEdit database. The data, NaviEdit data, Newport data, raw data. Here they are. These are the 6 different casts. If we open it, I can just open it with Notepad. That's the easiest thing to do. Then you can basically see that what I have here is really date and time and sound velocity. There are also some other information, but we're not going to use that. We're just taking the sound velocity as it is here, 1491.3. Date and time, we're actually not going to use. So instead, we will load the files as they are into NaviEdit. Let's try to see how we can do that. We'll import, and this time use the ASCII files importer. Once again, an interpreter, this time the ASCII interpreter. This is a 5-step wizard. So we'll add the files, pressing the add button, and then from our project, the data folder, NaviEdit data, Newport data, raw data, Newport SV, like this. We'll take all 6 CSV files or CSV casts here and load them. Next step is to always, when you have an ASCII interpreter, and this is very important that you do that, we need to use the correct or choose the right data type to import. And this time, this is an SVP data type, sound velocity profile. Let's have a look now. There are some predefined, and we can, if we select these templates, one of them, you can see the interpretation. And basically, we need to have depth and sound velocity. And none of these are actually giving us depth and sound velocity the way we want it. I have one here, but that's one I have created. As you can see here, that gives the depth and sound velocity. Then Navitronic on-off also, because that's one I have created. And then this one here is not working either. Correctly. So we need to create a new template. We do that by pressing the new template button. But once again, make sure the data type to import is SVP. New template. Here we have the data once again. Column 2 is the sound velocity. Column 3 is the depth. And that's basically all we see. This step here is where we are defining the column separators. By default, it is comma separated, and that is correct for us because the only thing we need to be able to establish is where do we find the sound velocity, that is column index 2, and where do we find the depth, column index 3. So then we go to the next step. That would be, we need to define the primitive column types. What kind of numbers are we talking about? Column index 2. In this case, primitive type is double. That is a number with decimals. We do the same for column index 3, like this. Click on the header label and choose double. Number with decimals. You can, to help yourself, enable display as formatted. Then you can see that the only thing we see are these two columns that we need, and they are shown in the right way. But this is only for information. So I will go now, press the next button. Output fields, we have an input that we have defined, but we haven't told NaviEdit anything about what we find in the different columns. So this is the input. We need to translate the data to the output. I don't understand what you're trying to show there, Duong. Speak again, what you mean? I thought I was talking. You can't hear me? Oh, you can't hear me if I said that. Duong. So what's the problem then? I cannot go backwards in this dialogue here. That's impossible, because if I do, then I have to start all over again. The only thing you should do from this is to press the next button. Wrong. Okay, I'll start all over again. Yeah, you got it. I need to create a new template. And then this is the first step. I'll leave it as it is. The next step would be then primitive column types, column index 2 should be double, column index 3 also double, and then I display as formatted. This is how it should look. So next step here, as I was saying, I need to translate the data so that I have the right output. And the output should consist of depth and sound velocity, because this is a sound velocity profile. So the first output field is depth, Encoding is double, that is correct. And now, where do I find the depth? I find that in index 3, like this. So now I see the depth down here. Right. The second output field, sound velocity. Once again, encoding is double, and I find it in index 2. The input or the data column is index 2. And now, as you can see, the output looks correct. Then I can press the next button. Here I have the possibility to convert the data if, for whatever reason, it could be that my depths are not correct. I need to add 2 meters to all my depths, but I don't need to do that, so I'm not going to do anything here. This is all correct. I will press the finish button here, and then I will call this one on, off, 4. This is the new template name, and say OK to that. And then NaviEdit, or the ASCII interpreter, will go back to step number 2 of the ASCII interpreter. It will probably select the one that you have just created, but you need to select one of the others and then go back to the one you have created. This is an inconvenience, but please do that. Just like this, so that you actually see the example of the data being correct. It's shown in the opposite sequence, but that doesn't matter. So now, next. This dialog is used for all these ASCII importers, and we don't have any. I mean, geodesy is irrelevant here. We don't have any coordinates. We don't have any time either. So we'll go to the next. I want to see the report, but I don't want to apply any notes to it. So I'll say finish. And now from hydrographic, I will create a subfolder that I call SVP. Like this, select it, and then say OK to that. Now, this is the first. There isn't a lot to look at in this kind of report. What we can, of course, see is that it's the on-off template, the 4 template that we've just created. And I don't want to see the other reports. So I'll just disable that and say OK. So here I have my 6 casts. In NaviEdit, you can perform or introduce or define a selection policy, both for sound velocity profile, but also for other items. In this particular case, we will use selection policy closest in time. So if we look at our SPD blocks, you can see that they have a start and end time. 19th of August 2011, but a little bit further down, you can see that data is collected on the 21st. That's 2 days later. So we have 2 different days, actually. And for the sound velocity here, if you look at the name of these casts, you can see that the name is telling us the starting time of the cast. You saw that each of these observations were actually included with a date and time, but that cannot be used here. We can only have one time for a sound velocity profile in NaviEdit. And that's the time that we have here. But the start time and end time is actually not correct. So what we will do is we will right-click on start with the first one here, choose the header editor, and now we will define the start time. You have to do that manually, one by one. In this case, it doesn't take very long, but this is then, in my case, I'll type it in, 19th of August. Do that really. 08, I tab in 08, and then it changes to August. And now this is then 2011. I can do that manually. It's very likely that your date format is different from mine, but you'll just have to then modify it so that it says 19th of August or 0819 or 1908, depending on the date format that you have. The time must also be modified, 11:01 0, and then 08. Time is also important. Seconds are, of course, not important. I would even say minutes may not be so important, but this is how it should look. And then you can say OK to it and be aware that you get this warning here, no pages were modified. Saving will only change the review status proceed. This is not correct, actually, but say yes to that. This is important. And then you can see that nothing happens, but if you right-click and choose refresh, you can also just press F5. Then you can see that the start and end time has changed. You have to do that on all 6 casts. Right-click header editor, and then this is again 19:08 to 0:11. And here 14:51:15, like this. Okay. So the funny thing, I don't know if it's probably not funny, but this information window here always pops out on the primary monitor. So you have to be really aware of it. And it's important that you acknowledge, refresh, and it's updated. So I'll just continue with the others. And of course, these, the remaining ones here are from the 21st of August. It's good for us that the file name tells us about the date, but otherwise, of course, you have a daily log sheet from the online surveyors that you can use. There is actually also a possibility to address or to load headers into header information and let that be or give you information about the date and time. That is quite complex. So this is a reasonably simple approach. All the time, remember to acknowledge, and then F5 to refresh if you want to make sure that you have done it correctly. Yes, and I'm completed. And I can see that by pressing F5 that all my timings are correct. It is possible to load all these files. I'm not going to do anything about it, but I can load, or rather, they're not files anymore. They are in the SQL database, so they are blocks. I can load all these 6 SVP blocks into the data editor. Just for visualization, here you can see I actually have 6 different blocks loaded. The current block is the one that I see here. This is the last, actually. But I also see the others. They are grayed out, as you can see. And the current is shown like this. I can toggle between them by pressing this arrow here. If you see my cursor at the top, it says previous block. Then I'm letting the previous block be the current one, just to see how they are varying. So basically, you can see that there is some variation. It's not anything dramatic or anything like that, but it's certainly worth to taking into account. So let me close the data editor. And now I will load all my Naviscan blocks once again into the head editor. Right click, head editor. You remember that we also did that yesterday to change the mount angles on the multibeam echo sounder. But this time, as I promised you yesterday, I'll go to these items or tabs or whatever you call them, one by one. First of all, here we have the instruments tab. You have done the NaviEdit e-learning and know that header editor is different on different types of data. Here, for instance, I can see it says here Artosonic 2000 series, this tab here, that tells me that it's a single head multibeam dataset. If I had a dual head, then I would have 2 tabs with the 2 heads represented. But anyway, I just got the list of people for next week's training course. I can see that there are 2 of you, that Ili and Dwan, you're also going to join us next week. Fantastic. Okay. There'll be a little bit of repetition then, but not too much. I have all my data here. There is a possibility, actually. You don't have to do it. I'll just show you how it works. In Naviscan config, and even though this is post-processing, it's really useful for a post-processing guy to have this information, because this is our configuration from yesterday. But I can actually open an SPD file. That's what I want to try to do here. Data, NaviEdit data, raw data. There's nothing here, but that's because it's filtering on extension bin, but I want to look at all files. So I'll just take the first one here and open it. This is the SBD file. And then if you do that, then you can really see how Naviscan was configured. This is very useful. Also for post-processing, to see how it was set up. One of the things that you can see here is that there's a side scan option. Snippet, also from a side scan option on the Multibeam Echo Sounder. But what you can basically see is that the name of the file has X underscore. This was the old or older versions of Naviscan that would give you that possibility to create an SPD file with side scan and one without side scan simultaneously. The reason, of course, is that the one without side scan is substantially smaller than the one with side scan. The ones without side scan get the X underscore in front of it. So even though it appears that I have side scan here, I really don't have it in that particular SPD file. But anyway, what you can see here, of course, and that is not possible to see if we look at the instruments tab here, is that the navigation comes from NaviPeg. Yeah. It does say NaviPeg external. That, of course, gives you an indication that it is coming from there. But you can also see that in this particular case, NaviPeg and Naviscan were executed on the same computer because we have the IP address 127.0.0.1. That's also something that is worth taking into account. A little bit further down, of course, we have the ultrasonic. You can see the port setup, UDP port. We were talking a little bit about that yesterday. 4000 and then 10.0.0.86. This is the IP address of the sonar head, as we were also talking about. Further down here, we actually have the snippet, UDP port 4006. Synchronized, it looks as if they have synchronized computer clock using GPS time in Naviscan, not in NaviPeg. But it's basically the same thing. But they're using the DSR, that is pin number 6. But apart from that, COM1 and ZJ GPS time. Doesn't matter if you do it in NaviPeg or Naviscan. NaviPeg runtime control, we also saw we have a gyro, CPath. Basically, this is a binary format. Same for the motion on COM4. So that's interfaced directly. So this data was splitted, or this cable was split. I think 2011, we probably didn't have this port sharing between softwares at that time. We have a Betty sensor. This is the height component. And basically, this is an output from NaviPeg called NaviPeg heave correction. Right. But Samuel, don't tell me that you have a question. Just ask the question. That's a lot easier. I would certainly hope that, or prefer that if you do it on the chat. If we try to look over here, you can see we have the side scan, we have the multibeam. Then we have something called GPS antenna. This is something that we need Yeah, how can you see that this is the main vessel? It is the main vessel, but how can you see that? And why are you saying it? RV instrument. I don't think I understand what you mean by that. Naviscan uses one object only, and that object is the one that is carrying the multibeam echo sounder. If you have a subsea scenario, that is typically an RV. If you have a surface scenario like we have here, it is typically the main vessel. So it is correct what you're saying, but that this is the main vessel, but I don't understand what you mean by RV instruments.
I meant.
No, please use the chat, Samuel, because I cannot understand what you're saying on the microphone. Now, the Betty instrument becomes actually three different instruments in, well, at least two different instruments. We have the Betty instrument here directly. Yeah, but they have not used this port sharing functionality here. So they could have done it if that was existing at the time, but this is something like 12 years ago, so it wasn't a possibility back then. Yeah, Kim, that is correct, but I don't think that's what Samuel is referring to. Generally speaking, you can say that in NaviPack, if you want to share ports between NaviPack and Naviscan, then the object that you are choosing must always be the object that Naviscan is interested in. The NaviPack object is always the object that is carrying the multibeam echo sounder. No, you can't share two objects. Yeah, you can, of course, but you cannot filter then. Here, I can, of course, only choose one object if I want to limit, but I can refrain from limiting by choosing none here, and then everything is being sent to the port sharing functionality. Yeah, what I was saying was this Bethy output, it results in a Bethy instrument here, but it also results in the GPS antenna, which is something that I'll come back to in a little while. That I think will also answer some of your questions, Duong, regarding the RTK and how to handle it. Right, if we continue here, there's not really anything I want to modify in this tab here, but I want to, in the next tab, the sound velocity profile, I need to select these profiles. I can either add a series of profiles or I can add an entire folder, and the latter is, of course, the most relevant thing to do. Add folder. Now SVP. Okay, and now all these blocks are loaded. Once I've done that, I need to specify a selection policy, and that is by time, and I'm using nearest profile. I could also interpolate, but I don't think there's any reason to do that here. I never interpolate, by the way. I want to have real data. I don't want to create my own, interpolation sound velocity profiles. So we'll use nearest profile. Window, filter on the window. This is in line with what we saw when we were loading the SPD files yesterday. So this basically means no filtering. Under options here, we talked about jar parameters. We're applying region convergence. Also talked about yesterday. Here, there's a possibility to say subsurface or surface-based. The only consequence of that is that if you have subsurface, then there is an extra tab that is called the pressure to depth tab, but we don't have that. Pressure to depth is, of course, the calculation of the depth of the object relative to pressure observations, a Bethe center. TX sound velocity, we talked about that yesterday. What is it that you want me to say, Samuel? One step. What do you mean? The only thing I said was that selection policy should look like this. I can give you this on the chat. So that you can study it yourself. Okay, I'll move on to options. Nothing in the Windows tab. Check sound velocity, we talked about that yesterday. What I'm saying, I said specifically add folder, because then it will take everything in that folder. Add folder means everything in the folder. Okay, back to options now. We talked about TX sound velocity yesterday. This is not something that I would use, really. The depth calculation, use heave. Yes, this is surface-based. In surface-based, we use heave. Not only that, we're also using induced heave, which is, we used to call that remote heave, which means that we will calculate the heave at the location where we need it. That is the location of the multibeam transducer. So we know offsets and we know heave at the heave location, but then we can calculate heave in any other location as well. We're also going to use Bethe. So we're not disabling the Bethe. And Bethe in this context is RTK height. Once we have Bethe, or RTK height, sorry, we're not going to use squat, because squat is typically, this is vertical displacement caused by speed through the water column. And basically, when we have RTK, everything is observed. So we don't have to worry about that. And I also think a squat table is, well, not really something that I would go for. The last thing here is actually reasonably important. We'll enable it. So what does it mean? Well, all the data that we are receiving are asynchronous in time. So they don't come in at the same time because they come from different sensors. We are using the data to position, in this case, this is multibeam. We're using the data to position the multibeam scans. This is the only purpose of what we're doing. Position and also the orientation. So in order to get the best possible position and the best possible orientation, we must interpolate between the observations. So I have a gyro 100 millisecond observation 100 milliseconds before the scan, and I have 150 milliseconds after the scan. Then I must interpolate between those two to get the heading at the exact time of the scan. But if I don't have a gyro reading, for instance, or a motion as it says here, but there's both motion and gyro before the first scan, then I should actually skip it, because then I cannot interpolate. That's the purpose of this one here. And it's always, actually, I think it's a good idea to do it. If you have a route survey where Naviscan is closing a file and opening a new one after 20 minutes, typically, then you can say Naviscan will always make sure that you have motion before and after. So you could have a repetition of motion data in those two files that are acquired right after one another. And that's not a problem, but it gives you the possibility of using all scans. But in this case, skip scans without motion. Geodesy, well, basically, what we see here to the left is our user geodesy in NaviPack and Naviscan. Always, by definition. So what we have, or are given a possibility to do here, is to convert the geodesy by applying a datum shift, and this datum shift is on top of the potential datum shift that you performed online. So if the online guys have done something wrong, then you can apply a new datum shift, but make sure that the sum datum shift of the online datum shift and yours here, a datum shift. And of course, you can also change if you require projections, an alternative datum, then that and the destination is identical to the source. It doesn't mean that you haven't applied any datum shift online. It just means that we are using the online geodesy by default until we change something here. Tidal data is irrelevant. We don't have a need for that because basically we have RTK height. I have no reason to use pressure block. actually don't understand why this one is included. You see here, surface-based, pressure to depth. Yeah, okay. We can still have pressure block even though. Yeah, but we don't have any pressure. Ultrasonic, here, there's a lot of possibilities of filtering. I didn't talk about that yesterday, but one of the things that we should do is to enable or define the quality threshold. Remember from the report or the metadata yesterday, we had qualities 13 and 14. So if I enter 13 here, it means that I will accept qualities 13, 14, and 15, always including the one that you specify here and the ones that are better. Deselected beams, further up, we can deselect beams that could be outer beams. This was something we used very intensively when we had, basically second generation multi-beam echo sounders. They were often very unstable on outer beams. That's not the case anymore with flat array multi-beam echo sounders. So, but it is possible to define different intervals. You always define the beams 1 to 5, and then another one that could be 252 to 256, for instance. Those would be the outer beams then. Now, further down, we have something we call include filter. In order to have an include filter defined, you need to specify the slant range, maximum, minimum, and the opening angle, maximum, minimum. You can imagine it's like it's not really a rectangle, but it looks a little bit like a rectangle, even though the slant range, of course, will be parts of a circle. So include filter means that everything outside the region that you can define here is being excluded. On top of that, you can also define up to 4 different exclude filters. These exclude filters must be inside the include filter, of course, because everything is outside is already excluded. And that could be a smaller area, typically something around, if you have a multi-beam survey associated with a pipeline inspection job, typically the pipeline pipe tracker is underneath the multi-beam echo sounder, and then there would be noise in fixed locations all the time. And then you could define 2 exclude filters that would actually exclude this noise. Yeah, those of you that are participating in next week's training course will know that I don't use that. I will much prefer, because this is not very accurate, and it might vary slightly. And it's really, really easy to get rid of using the cleaning functionalities in NaviModel, SCAN primarily. Further up, we have something we call TPE filter, total propagated error. In NaviModel, we do TPE. We don't do that in NaviEdit, or we can do it in NaviModel, but here we can take advantage of multi-beam echo sounders that are actually able to report these values. And if we have, that's not the case here, but if we have that, then we can filter on some of the values. That could be cross-track error exceeding a certain value, a long-track error exceeding a certain value, etc. That's not the case here, so we'll just leave it as it is. On the properties here, it just shows some information regarding, this is the current block, as a matter of fact. Not so relevant here. I can apply notes if I want to, and I can also see the previous notes that I applied during import. I didn't apply anything. I can also see the report, but that's identical to the one that we saw initially. Plus, as you can see at the bottom here, I have deleted 2,854 beams on this particular block. This is the first block that we have here. So this is my settings. I will say OK to that. And then very important that you acknowledge here. And this is going to be on all, I can't remember how many, there are 139 blocks simultaneously. So I'll just say yes to that. You can say in many ways, this is a little bit like a batch editing session. If I right click again and refresh, then I can see that I have edited the header, but I already did that yesterday. I can also see that the SVP profile is loaded. This is good. There was actually one thing that I forgot to do. 2 seconds. This is related to the question that Duong had about RTK height. 2 seconds. I'll just find the setting because I can't remember it. Yeah, I need to load all blocks into the head editor again. The good news, of course, is that it doesn't take very long. All 139 blocks or whatever it is. And now this instrument down here, this is actually an instrument, the GPS antenna, because I will have to recalculate the Bethy. The Bethy instrument comes from NaviPack. It is really based on the RTK height. The problem is that Naviscan doesn't know anything about the antenna height. That's not part of what's being received from NaviPack. So therefore, I will manually have to do that. I have to do it because I will recalculate the Bethy height with a new with new data that we have here, a geoid model, for instance. So I will double click on the GPS antenna NaviPack heave correction, and then I will enter the height of the GPS antenna. And notice, you might wonder, why is this negative? It is negative because in post-processing, the set, this is actually the only exception we have, the set is positive down. All offsets are positive up online, but they become positive down in post-processing. So it is this one here that I will give you on the chat, as you can see here. And remember, it is the GPS antenna that you must specify. You can see it on the chat now, the value that you should have. Okay, to that. And then here, remember to acknowledge. So now I will load the data into the data editor. Remember, we have these two editors. We have the head editor that allows us to modify general information regarding the different blocks. And then we have the data editor that allows us to edit the actual data that was acquired. So I will not take more than 4 blocks because I'm not going to do that much. I'm only going to look at the data and check that I don't have any gross errors or anything specific that I need to do. And I cannot load all these blocks into the data editor simultaneously anyway. So we'll just take the first 4 ones here, right click and choose data editor. I'll select all. Okay to that. And then this will take a little while. It's always the multibeam that takes time to load. I would say window, tile. So here I have my data, 4 blocks. And you can see that I have 4 blocks. If you look at the caption here, 4 in brackets. And if I toggle, press the arrow, that's just something I know. You can say that I asked the online guys what it was. That's basically, but Raymond, good question. It is important that you make a note of that. But that's because you forgot to load it. You have navigation. If you don't have it, let me see. The easiest thing is just to reload and check everything. Yeah, you can go back. Just close the window and then select all when you load it. Now, I can toggle between these blocks, as you can see here, by pressing this arrow left and right. This was the same thing we did with the sound velocity profiles. What I would look at would typically be the navigation, if there's anything wrong, but this is RTK, so I would assume that the navigation is okay. I would also definitely look at the GPS height here and see that it is a constant. It doesn't all of a sudden jump if I lose RTK. And of course, it will jump and become very unstable in terms of the height. But this is, of course, what is being sent from NaviPack, this value here. We're also actually receiving the Bethy, because that is checking the geoid undulation. This is in line with what you were talking about, the geoid undulation, the difference between the ellipsoid, the WS84 ellipsoid, and the vertical datum that in this case is represented by a geoid model. We'll come back to that later on. Further down, we have the heave here. That's also one of the things I'll be looking at. Is the heave centered around 0? It should always be centered around 0. If we make a fast turn, then of course a horizontal acceleration, a turn would give a horizontal acceleration that should be excluded from the heave data. It only is included if the motion sensor is aided. That means get information about speed and position. So basically, you can see that is certainly looking very good here. Heave is always centered around the zero value. No sudden jumps in pitch and roll either. A gyro for that matter. And then we can have a look at, we can maximize the multi-beam. And then there's a possibility to play back or fast forward. And then you can see how the data was looking at the time it was collected. Not just the multi-beam, but all other blocks are also shown. You can see the red crosses here are showing the corresponding readings on the different sensors. So in principle, you can do this from any of the window. Yeah, we'll come back to that, Samuel, about the RTK reference. So I'm reasonably happy. I'll stop my fast forward and then have a look at the time. If you look at it, the GPS height says 35 seconds in terms of time. The gyro says 35.267. Bethy is also 35. Heave 35.267. That's the same as a gyro because it comes from the same source. Whereas Bethy and GPS height comes from NaviPack, and so does the navigation. That's almost the same. Multi-beam 35.262. Roll 267. Same as heave and gyro. Pitch, of course, the same. So this tells us that we don't have everything, but I mean, I don't have the exact pitch that corresponds with optimum value, and that's how it's working. Now, let's talk about the RTK. Let's talk about geoid versus ellipsoid. Samuel, the RTK is always referring, or output from an RTK is always related to the ellipsoid, always. But you can apply a geoid model online as well as offline. I want to show you how this can be done in post-processing. It was done online, and we want to improve it offline. What happens is that NaviPack knows, of course, it has the GPS height here. This is an observation coming from the RTK. But we have also applied a geoid model online. And so with knowledge about the geoid model and, of course, offsets, we can calculate the Bethy value. The Bethy value is the height of the 000, the CRP. So what we do, we take the GPS height, subtract the geoid undulation, we even subtract the heave from it, because if we don't subtract the heave, then you can say RTK height and heave are really observing the same thing. But the RTK has an absolute accuracy. It will always be correct, whereas the heave has a relative accuracy. It will always be centered around 0. But if we combine the two, then of course we get an improved precision. And that's basically what we do by constantly subtracting the heave, calculating the Bethy, and then in post-processing in NaviModel, we will add the two together once again. But I can improve my Bethy because I know a lot more about my position development in post-processing. So let's see how we can do that. I will right-click on the Bethy and then choose Recalc Bethy, like this. And now you see why I need to know something about the offset, because that information is not available in Naviscan. But I need the offset of the GPS antenna so that I can calculate down to the 000 for the CRP. That's one thing. Another thing is I need a geoid model. And I have supplied you with a geoid model. You press the browse button to the right here, and then in the data that we have here, on-off data, I have a NaviEdit data, report data. I have a geoid model. This is the Danish geoid model, DK geoid, in a binary format that NaviEdit and NaviPack, for that matter, understands. The Danish geoid is a very good geoid. It could even be the best geoid in the world, not because we're better at defining geoids than other people, but because Denmark is a small country and we don't have any mountains. So therefore, basically, set is always the offset of the C to the CRP. Always, like in by definition, Samuel. But because it's such a small country and because we don't have any mountains, well, we have one mountain, but that's only 148 meters high, so that's not really, doesn't count, I know. So our geoid is not very dramatic. That's why it's a lot easier to define. But anyway, we'll take this one and open it. Now it's being defined. And by the way, it doesn't matter which block you're using because this is just an example. But pay attention to the Bethy here and see how it improves. I'll say OK to that now. And now you can see that it becomes a lot more stable. There's also a small offset between them, a few centimeters, but that's not so important. What the important thing is that it is very stable now. This is the Bethy value. So because it is depending on the RTK height, we know that there is some white noise in the data. So therefore, we will filter the Bethy. Right-click and smooth. We will smooth the Bethy like this. Right-click on the Bethy, and then when we're smoothing in NaviEdit, we're using what we call a wavelength. So it's really a sine curve, a running average sine curve with a certain wavelength. The longer the wavelength, the smoother the data is going to be. So I'll use a value of 15 now. There you go. I'll just take this one here. I'm not going to do all the others, but you could treat these as one, but that's not relevant here. I'll just take this one here, say OK to that. So now I have my Bethy, and compared to what we saw before, you can see that our Bethy is substantially more stable, and it is actually also more correct to do it like this, because on top of this, you can say this is long-term vertical movements represented by the Bethy. Short-term vertical movements is represented by the heave. So we add those together to get the vertical movements. That's why we are subtracting the heave from the RTK height, so we can smooth, and then we add the heave afterwards in post-processing in NaviModel. So this is basically handling of something like this in NaviEdit. So we will pretend that we have checked all our data. We haven't done anything, so I'll close my data editor here. Save changes, no, not necessary, because we're going to recalculate the Bethy now as a batch process. Otherwise, we had to do this manually one by one, and that will take a million years. We'll do this as a batch process instead. Yeah, Kim, that's a good question. You can revert, of course, you can recalculate, because it's the raw data is staying there. The raw data is the RTK height or the GPS height or the ellipsoidal height. And so you can recalculate the Bethy as many times as you want with different parameters. So I'll take Naviscan now, just highlight it, and then here under Tools, I will choose Batch Job. So then all Naviscan blocks will be loaded into the batch process. Now, the batch process is a tool that you recognize this from the e-learning, but that allows us to make different actions in a certain sequence on blocks that we have loaded into the batch process. In this case, all SPD blocks related to the hydrographic project. So the first thing we do is to press the Add button to define an action, and that one is the second one, recalc Bethy or GPS height by GPS height. Not this one here, ocean, because that's pressure to depth conversion. But the second one here, recalc Bethy or GPS height by GPS height. And then next here, the sensor is the Bethy sensor and the active sensor. We only have one sensor, and that's the active sensor here. And then finish. Now, it says here, GPS antenna offset, edit and header, but we saw it was correct when we did it in the data editor. That's this minus 2.61. The geoid file, it is actually remembering, but let's browse to be on the safe side and locate file here, this dkgeoid.gbin file. Open. And that's the only thing you need to do, actually. Okay to that. And then another action, add another action. This is called smooth points, like this. See that there are a long series of actions that you can perform here. Next, which sensor are we going to smooth? That is the Bethy sensor, active sensor. Finish. And a wavelength of 15 was what we saw or used. I think that is fine. Okay to that. So now I have two actions, and I can now start processing. One by one. This takes maybe, I don't know, half a minute maximum. But if I should have done it manually, it would have taken several hours. And here I don't make mistakes. I might make a mistake on all of these, but certainly if I have not specified my items correctly or my parameters correctly, then of course they will not be correct. But at least I will use the same parameters throughout. I'll just go through and see everything is done successfully. Yeah. So I will close the dialog, and then I can press F5 to refresh. And then you see that I have modified my item, but the Betty says OK B. OK, batch processing. I can also try to look at the report that's accessible from the Explorer panel here. If I double click on the report all the way to the bottom, you can see that I have modified the Betty using the mount angles here. No, not mount angles, but mount offsets. Here I change the offsets. Here I apply some velocity profile. And up here I've done the cleaning. Let's see if yeah, that's it. Okay, to that. This is fine. So in theory, I am finished with NaviEdit here. And then I'll open NaviModel. And this time create a new project that I will call hydrographic. And place it in, I will browse and place it in my NaviModel project, or sorry, my NaviModel folder. And then create. As you can see here, I have now got two different projects. The cleaning that I created yesterday and hydrographic that I have just created. So now I have my hydrographic folder in NaviEdit. Let me just show you one thing. If I explode and then I select the first block, doesn't matter which one I select, but if I right click on it, even from NaviModel, I can open it in the head editor. So I have access to the head editor even from NaviModel, and I can do exactly the same things I did from the job planner NaviEdit. I can also load it into the data editor if I want to do that, as you can see. But of course, there's a lot of other things I can do in NaviEdit that I cannot do from NaviModel. But now I want to create a terrain model. Let me just to be absolutely sure that I'm not doing something stupid. Yeah, no, that's okay. I'll just remove. This was the old one. I just want to make sure that I'm using the right cell size. So that's what I will right click on Naviscan, same as yesterday. And this time import MBE point to DTM. Again, we also did that yesterday. All these blocks. Okay to that. Just one model. This is also what we did yesterday. And then I'll call it hydrographic. We'll use a cell size of 20 centimeters like we did yesterday. But let's have a look now at some of the things for the options. If I press the DTM button, then I can choose different surfaces, as we call them. Let's just include minimum and maximum. A cell is represented for a surface, an average surface. Each cell is represented by the average observation inside that particular cell. If we have a minimum model, that is our minimum surface, that is represented by the minimum observation, and a maximum surface is represented by the maximum observation. And we can have those in the terrain model simultaneously, so we can toggle between them. And that's basically what this is all about. So I'll say okay to that. Now there's also, and you can see now in blue here, this is basically the deviation from what is default. So I have three surfaces: average, minimum, and maximum. Options here, read intensity. Intensity is side scan, but there is no side scan, so it doesn't make any sense. But I can also do some cleaning, automatic cleaning, for instance. I can calculate S-scan score on the data automatically and then apply a threshold afterwards. But we learned yesterday that we cannot clean everything with S-scan, so therefore that doesn't make any sense. And besides, the data is already cleaned. And the same with EC3D further down here. So I'll just say okay to that, and now we get another deviation from default. And basically, that is what we want. I'll say okay to it, and then NaviModel will start loading. As yesterday. Threshold. What do you mean you don't have any threshold? Doesn't matter, because we're not going to use scan, Samuel. Don't worry about that. We have already cleaned the data, so you don't need to have a threshold. We didn't enable it. On the contrary. Okay, I want to talk a little bit about NaviModel. I promised that. Yesterday, this is NaviModel cleaning. I'm not focusing on the cleaning. I'm focusing on NaviModel features while we are loading the data. Let's have a look at some important features in NaviModel. In NaviModel, we have what we call an unlimited model size that is based on the quad-tree principle. It is unlimited, the model size, because we are creating the terrain model on the hard drive. So, of course, there is some limit, but that's more based on the capacity or the empty space on your hard drive. Come back to the quad-tree principle later on. We're using what we call a triangulated regular network geometry type. This is what we do when we do multi-beam data or calculate multi-beam data, but we also have something that we call TIN models, irregular network types, typically single beam or theoretical models. We use or we apply the TIN geometry type. The triangulated regular models include by default the raw points. You saw that yesterday. We have the raw points there. You can create average, minimum, maximum, and other surface types or model types. And we can even interpolate the models, that is, filling gaps in a qualified way. We have cleaning functionalities, automatic, semi-automatic, and manual methods. You saw that yesterday. And then we have some add-on modules, conventional digital terrain modeling. That's what we're doing right now. Pipeline inspection, we might do that later on. We can integrate video in a NaviModel project. Online 3D visualization, primarily something we use in a headless display. We have a judging module that is a special combination of NaviPack and the headless display. It's called UCA. We can visualize catenary and cable lay calculations. We have a catenary and cable lay module. Can also be visualized the outline of cables, anchor wires, etc. in the headless display. And there are other modules, and the number is growing constantly. Yeah, raw points, of course, is the reason why we can do cleaning, because we're not cleaning on the models, we are cleaning on the raw points. The quad-tree principle, quad 4 means that we are using the quad-tree principle as our strategy for fast handling and visualization of large data sets. We are working on different levels. When we go from one level to another, we are subdividing cells, each cell into 4 cells for each level here. 1, 4, 16, 64, etc. When we zoom out, we are going up on a higher level on the terrain model, and then when we zoom in, we go down to the lower levels, and thereby getting a higher resolution, but only of what is on the screen. The rest is clipped away. When you are creating a terrain model in NaviModel, you define the cell size. That particular cell size, in our case, with 20 centimeters, is identical to the 32nd level. So when you create a terrain model, all 32 levels are being populated. And then if you do cleaning, then all 32 levels are being updated. But of course, only in the areas where you have done cleaning. We don't call it updated. We call that we say that we re-index the terrain. Quad tree is useful when you have what we call a horizontal approach. This is the 2.5D that I was talking about. So all cells are scattered horizontally. If we also wanted to do this vertically, then we should have what we call an octree, where also the vertical component was subdivided into cells, so 2 by 2 by 2. Illustrated here, this is a pipeline inspection job. You can see the cells have a certain extent on the monitor, and if I zoom in, the extent on the monitor is the same, but it covers a lot less ground, so the high resolution, of course, to the right, and low resolution to the left. The models and the raw points are living on the hard drive, as I said, not in RAM, at least only temporarily. We say that we need to have a high I/O efficiency in order to be able to move data from the hard drive to RAM when we're changing the scale and thereby the resolution. This should be the case both for the model itself, but also for the raw points, as you saw yesterday. TRN geometry here. We have square cells. We subdivide them into triangles to the right here in order to ensure a smooth transition between cells. So we're introducing corner points here, and they are, of course, the average of the cells that they are neighboring. The tint geometry type here, an irregular network. You can see zoomed in here, you see the triangles. It does matter how we are performing the triangulation. We say that we're using a so-called Delaunay triangulation principle that says that circumscribed circles between corners of triangles must not contain other points, exemplified by this simple seabed here with 4 points. Of course, you can make 2 different versions of the triangles. I have written the circumscribed circles, and you can actually see how the solution to the left here, the circumscribed circle, contains other points. This one here in this case, and that one in that case. Whereas to the right, they do not. And I think also intuitively, the solution to the right is the better one. So Delaunay triangulation. Interpolation. We are talking about primary and secondary cells. Primary cells are cells with observations in them. Secondary cells are cells that are the result, at least the depth value or the attribute value is the result of an interpolation process. When we are doing interpolation, we are looking for, in this case, this particular secondary cell, we're looking inside a search circle that we're also defining. You define the size of this search circle, and then NaviModel will simply look in all directions for this particular secondary cell. Once it meets a primary cell, it will not look further in that direction, and then it will simply take all primary cell observations and add them together and also weight them we're using what we call inverse distance weighting. This is also the same method or the same procedure or principle that we were using when we talked about surface navigation instruments, USBL instruments. We are weighting relative to inverse of the quality. In this case, we're saying that the quality is represented by the distance between the secondary cell and the primary cell. And that's basically what you see down here. This is the weight for the particular primary cell attribute value. Then we're adding these together, all these values, and then normalizing by using this value here, so that we get the attribute value or the depth value of the secondary cell. To the left, we have interpolation. To the right, we have extrapolation. Oh, sorry, the opposite. Extrapolation to the left, interpolation to the right, because to the right, we have primary cells all around the circle here. To the left, we only have in a certain direction. Yeah, that's what I wanted to talk about here. In the meantime, as you can see here, I have created my terrain model. I think it looks reasonably nice. But as we were talking about interpolation models. You can see here that I have some gaps. I think up here I have the largest gap. I can actually measure the gap. There is a measure tool here. If I measure this distance here, it is something like 6 meters, which basically means that I want to interpolate 3 meters from each side. And 3 meters here is the same as 15 cells. I'll delete this. You just select it and press delete on the keyboard. So I'll probably take 16 cells just to be on the safe side. In order to be able, you saw that we could interpolate and we can extrapolate, but I want to extrapolate as little as possible. I do that because otherwise the extrapolation on outer skirts here would be actually going away from the terrain. I don't have anything here, so what I want to do is I just click on the terrain model and press the space bar, and then it will be modified. I can also zoom in and do it again and press the space bar. There are other ways of doing it. It's important now that we are actually doing this interpolation before the break, because it will take a little while to do it. So I'm going to perform the interpolation relative to what we call a boundary that is giving me the outline of my terrain, so that we don't go far away from the data that we have here. As little extrapolation as possible. So we have the hydrographic model here. If I right-click on it, I can choose Create Outline. Right-click on hydrographic. Let me show it again. Right-click on hydrographic, Create Outline, like this. I will create an outline for the entire DTM. For the DTM, and now the level of detail, I want to make that customized. Basically, that means that I am defining a maximum error. This is basically the maximum variation I want to accept on my outline relative to the ideal outline, because I need to generalize it to some extent. So if I choose an error of 0 here, then it will be exactly at the cells, and I don't want that because that will give me too many points on the outline, and then interpolation will take 1,000,000 years to perform. I don't want to have gaps because they are gaps inside here. They are not relevant to me because the whole idea of doing the interpolation is to fill the gaps. So I don't want the gaps to be part of my outline. So I'll use these settings here. And then say OK to that. It says large results, but we will just continue with large results. It's actually not as bad as it sounds. Now I got it here. Find it under shapes, hydrographic, and then polygon. If I zoom in, you can see how it looks. It's actually quite nice. 4,233 points. That's a little bit much, but I can still use it. I hope. It's a little bit much, I must say. I might consider using or creating an outline. Let me change the name here to polygon_5 to say this is 0.5 meters. To create another one here, right-click, create outline for the DTM, and this time 1 meter. Okay, to that. And this time I don't get the warning. And now here it is. This time only 1,661 points. I think I'm going to use that one instead. Let me call this one 10. This is then. There isn't that much difference between the two, but there is a difference. You can see this is very generalized. Now, let me try to use this one here, the one that's called polygon_5. This is the 0.5 error. So I will, from hydrographic now, right-click and choose surfaces, and then add interpolated. Please don't use add interpolated long line. That's a totally different functionality. Add interpolated here. We will base our interpolated. There always has to be a source for this. I'll use the average surface as my source, and then I'll give it this one average 16 to say that I'm using 16 cells or search radius of 16 cells. Average 16, and then I will change the search radius to 16 cells. And for the boundary, the browse button, I'll take polygon 5 here and say OK to that. The good news, of course, is that we have 20 minutes, so it should be able to complete this in 20 minutes. I'll give you this on the chat. And then I will say OK to it. And now it's processing. You can see that it's using all the cores for this. This is, of course, good news because there's a lot of points. Try to imagine we have 130 million points. And basically for all these points in the polygon, 4,600, I need to check for each of these points, is it inside or outside when I'm interpolating? So it's bound to take time. My colleagues in the software department are telling me that one of the most difficult things when it comes to software development is to calculate or to create a progress bar or progress calculation. See, didn't take too long, not on mine at least. And now I have actually the hydrographic. Look at it. It is automatically swapped the surface type. Look at it. I have different surface types. Average 16, but I also have average. So there's not a lot of difference between the two. A little bit further out, but if I go to the area up here where I had this large gap, it's probably easier to find it if I choose average. Here it was. This was my larger gap. If I choose average 16, you can see that it's now closed. And that's exactly what I wanted. Okay, guys, 11 o'clock, coffee break. Let's meet again at 11:20. See you then.